So our very first PocketQube mission was Smog B, and later on Smog 1. These were electromagnetic pollution measurement or spectrum monitoring satellites on a 1-unit PocketQube. And the secondary mission was a dosimeter, a very tiny dosimeter, which right now is already a commercial product featuring our smallest dosimeter. And the third experiment was a magnetically hysteresis material, which is able to reduce the orbital lifetime of the satellite.
3, 2, 1.
It was launched with Electron by Alba, Electron was launched by Rocket Lab, and on board was the launcher of Alba. And then Smog 1 was later launched by Soyuz 2 rocket in 2021. We have some nice images from the deployer. There you can see 2 Hungarian satellites. One is ATL-1, I'll skip that for now, and the third one is Smog B. And these are the aggregated results from our mission. This is a global electromagnetic pollution map of our planet, and yeah, this was the goal for this educational satellite. So I'd like to highlight that this is built by students and lecturers at the university, which is valid for all of our satellites. Okay, so we have a ground station on site. We have 2 antennas. One of them is a 4.5 meter dish with a backfire helix feed. It has more than 20 dB of gain, completely automatic and automatic tracking and reception. And we are using an SDR for reception, and we are able to input 1 kilowatts of RF power into the antenna plus the 20 dB gain. And the other antenna on the next slide is a 3 meter dish. Right now it has an S-band student-built polarization diversity feed. The dish itself has 35 dB of gain based on the dimensions, and then the additional gain of the antenna comes on top of it. This also uses an SDR receiver and completely automatic tracking and reception. So our latest latest mission was MRC 100. The name implies the 100th anniversary of the Radio Club of Budapest, the Radio Club of the university. And it's a 3P PocketQube, also with single point of failure tolerant subsystems, redundant, and it is mainly host of different universities' experiments with some of our own, mainly remote sensing experiments on board. So it was launched on a Transporter 8 mission last year in June, along with ROM Space's satellite, and it features a UHF uplink and downlink with variable data rates, so we can change the data rate on demand based on the quality of the pass over our ground station, and it also has an S-band transmitter. S-band transmitter. So now here is our latest mission, which is in development, NMHH1. It's a 3P PocketQube, also redundant, single point of failure tolerant. It has deployable solar wings now. Uses RP2040 microcontrollers exclusively. We tried to standardize the backplate of the satellite to reuse it later on, and then it's able to communicate through CAN and one-wire UART. And this is our platform that we would like to commercialize later on as a module. It is capable of, it's a redundant communication onboard computer and power supply, all in one PCB. As I said, redundant, variable data rate, and CAN one-wire interface, and it uses the PocketQube protocol, we call it. It's a modified CubeSat-based